name's Lee. I'm with MHI Service. I'm here representing Midgley Huber. I'm here to talk about all your fans, anything associated with your air, basically. I brought down some things here from Price. I don't know if I got one for everybody, but there's quite a few here on your Price. This is your VAV box. I thought it'd be a lot easier if I just brought a VAV box in, because the rest are already in the ductwork, ready to go. VAV box consists of a damper with a rubber blade and a traverse to measure airflow. That is the extent. I'll let you guys pass this around and look at it. Other than that, Scott Yamas is going to take control over it. They're going to put their own actuator on it, their own controls to measure airflow. This airflow measurement tool here, he was talking about on the Phoenix earlier, about how you put a 90 on. This one here, you can do the exact same thing with on a VAV box. If it's mounted with a 90 right on it, doesn't matter. It'll still measure the airflow, does just fine. So, maintenance-wise in this, every once in a while, I would recommend undoing the U-bolt on whatever actuator they decide to put on it. Make sure it turns. That's it. Clutch it, open it, close it, make sure it closes. You're going to find on these, they have a rubber seal on the damper. If the seal starts to go bad, you're going to bypass a little bit more airflow. But as long as our flow tool is reading properly, it should compensate for it and shut off the damper a little bit more. So, any questions? I'm going to try and go through a little bit quicker for you guys. Try and keep your attention a little bit easier. So, anything else you guys want to go over on a VAV?
You don't know the controllers that's going on?
That's all Scott's. I don't know what you want to talk about right now. Oh, you're with UVU then? Yeah. Okay. That's Yamas then. That's all Yamas's. So, that is all Yamas's. They're going to put their own controller on. We have a control package we can put on it from Price. Usually they don't like our pricing, so they can do it cheaper, so that's what they bought, is what you see.
Everything that's
Connect square to one end, round to the other end, it's done. I mean, I'm sure some of them are going to have dampers probably, or hot water coils, maybe. Most of them. So, but again, hot water coil, going to have a valve controlled by Yamas. So, other than that, I mean, that's all there is to a VAV. I don't know, is there any fan power boxes here? Or the VAVs? Okay, so we don't need to go over fan powered boxes. Boy, I don't know if there's anything else. Every VAV is designed for a specific size. Here on the side of the box, you notice there's a chart here. For specific CFMs, you need to put a specific box in to be able to move that CFM. Same thing with his Phoenix valves he was talking about. You can't take a 4-inch valve and move the same amount of air you're going to move through a 12-inch box. So, I mean, that's on a box, that's all there is to it, is make sure you get the right box. That's the engineer's job, that's what he's supposed to do. He's supposed to sit down and go through all them, so when we get it, you have exactly what you wanted. And then the balancer, I'm guessing you're doing the balancing, Phil?
I'm with UNBC,
okay.
Commissioning agent.
Okay, you're
but
the commissioning agent. BTC, so BTC is going to go through, it's all changed since I'm working with you guys. So BTC is going to go through and verify that every box is moving the CFM that was set up by the engineer. So, and then that'll all be compensated by your fans on the roof. They should all be, hopefully they're all on frequency drive, so we're either going to speed up, slow down. So, same thing on our exhaust fans to maintain the static in the ductwork. So, and that's pretty much it for these. Other than these, everything in mine now is pretty much out in the labs, in the fields, and in the penthouse.
Coils are before?
Coil would always be after, usually. Coil will always be after. On a VAV box, or any type of a box, how fast you move the air through determines how much heat or cooling ability we have in the coil. And so this is always your high pressure side. So if we ever put anything here, it would take twice as thick of a coil to pick up the same amount of heat you need on this side, because your airflow is moving lower.
Static pressures generally.
Yeah, I mean, I've seen these as high as 3 and 4 inches, and I've seen them as low as a ½ inch.
This system, looking at the preliminary balance reports, looks like they're going to function about 2 inches duct static to 2.5 at their sensor location down
The high pressure?
here. On the medium pressure. Yeah.
That'll be on the round side.
You know, the 1 inch low pressure?
Less than 1 inch.
Yeah, I would guess over here you're going to be
They would call that low pressure, and they typically shoot for 3/4 of an inch or less.
If you get too much pressure on your leading side, you're going to get a lot of whistling. So, and usually if you walk in a room that you got a lot of whistling, Either it was sized with too small of a box, so they're trying to ram it through real fast, or you've actually got a real problem and we're moving too much air through it.
So see the pitot tubes on that again. That's different than what we have.
This one here is actually made a little bit stronger. Most you have, you can't grab a hold of them like this and walk around. You'll snap them right in half.
The ones you have, do you have like, is it a one-port sensor or is it a straight line?
It's just a tube going in with several holes in it.
Yeah, this is actually gonna take a larger sample
The
of
purpose
what's
of,
actually going through.
the whole
So
purpose of this,
will be more accurate.
yeah, say you put a 90 on the one you have, your airflow is always gonna be stronger on the outside of that 90. And so if your tube happened to be a little bit higher, it's always gonna read a miscalculation. So here they try to traverse it, and I believe there is a total of 12 holes drilled across here. So even if there's low pressure on one, between the average of all the way across, it'll always, and if you notice, it's not set straight up and down. It's actually in the X configuration to try to make it to where it picks up a little bit better airflow no matter where it's coming across.
And the discharge or control damper on the other side also will affect the
Yes.
air patterns as well, which is an inferior flow device. You know, the balancer will calibrate it at one position, then as that damper closes, the controls may say 200 CFM, but it may be 220 or 225. Your accuracy is going to go down typically in some of the other pickup sensors. That one is going to be better adaptive to what the VAB box is doing.
Any other questions on this?
What's the colors on the tubes?
One's for low and one's for high, basically.
Red's for high, some of the
Red side?
Yeah. I don't know, because a lot of times I've seen people pull the tubes off, put them one wrong ones. Then when you're taking measurements, you're like, what the heck?
Yeah.
So I always just tell everybody, one's for low, one's for high. If you're not getting a good reading, flip flop them, because it'll probably come right back in. So I gave you just a little bit there on them. Like I said, there is virtually zero maintenance on these. Clutch your motor, make sure the damper moves, opens, closes. You'll hear it when you close. You'll hear the big old pop in your ductwork upstream, usually if you close it fast. So, you know what I mean? Virtually, there's gonna be more maintenance on the control side of it. And on the controls, you should be able to open it wide open and verify your airflow's changing, close it, verify your airflow shut off.
Is that marked on the shaft end?
Yes. Line?
Yeah.
Yes. So, yep. If you do need to, in these, and you're feeling real aggressive, you can change the damper on the inside of them. It's usually cheaper to buy a new box by the time your labor's said and done. But these do come apart here pretty easy. So, 12 screws here, all we got to pull out. So, very simple.
Do you guys use Magna Helix or go around with that? So you'll notice that has gauge port and caps on there. So you can keep it hooked up to the control. If you want to measure your velocity pressure, you can keep it hooked up to the control without, you know, and measure the drop without affecting anything. And then just make sure you put the cap back.
Get a different reading than what the computers, or different way.
But yeah, just to back up what the computer's reading, and then the little graph on the side of the box will give you a good ballpark figure of based on that pressure drop of what flow you're moving.
Yeah.
And then you can compare it to your Yarmouth controls.
Yeah.
You can get that flow chart on the box online. You'll see a sticker off the.
Actually, I think you can.
I would
Pretty
be-
much standard.
I'd be surprised, I mean, it doesn't matter whose duct it is. 8 inches, 8 inch, 10 inches, 10 inch.
Yeah, they're standard.
Just in my startup days, I always used to have to peel a little chart out so I can get my flow
Mhm.
balance in the ballpark before.
Yeah, I'm sure, if you guys are looking for something like this, you can either go back through Rocky Mountain, they get a hold of Andy Ely. There's a part number here on it. So I'm sure if you wanted it, they can get it for you. Have several of them if you want them. But I mean, 8 inch duct's 8 inch duct, doesn't matter if it's price, doesn't matter whose name's on it.
That's true.
So, yeah. Any other questions on this? How about if we run out and do a little bit of hands-on with maybe some dry steam humidifiers? Get you guys. HI Service here representing Midgley Huber. We're here to talk about the dry steam humidifiers. So on this particular dry steam humidifier, this one's a little bit different than the Nortex. This one actually has a stainless steel cleanable tank. It has 3 heaters inside of here. Be careful you get up in here, it's 460. Heavy grab a hold, get pretty good. Typically the biggest problems we have in this is people don't clean these tanks enough. They build up with some scale. You guys call me, some humidifier doesn't work. I come out, open it up, yep, but it doesn't. So, and I can't answer how often these need to be cleaned because it's all dependent upon your water quality here. I don't know if we're running softened water to them, do you guys know? So, or if it's regular water, depending on how much it is used is going to depend on how often it needs to be cleaned. So, here on this one we have a fill line coming in here, a solenoid valve to control it. In this T up here in the top, there's a screen. That screen needs to be pulled out and cleaned periodically. So, okay, it's right here in the back side of this T. So, we have our fill valve that fills it. We have 3 probes inside of this tank that monitor the level. We do it with electronics. So we have a low that'll shut it off. We have a medium that when it gets to that, it fills back to the high point. We have a tank sensor here, just a standard Johnson Control tank sensor. You need one, run over here to RSD and get you a new one. There's no reason. The nice thing is about the dry steam is everything is done through plugs here. So if you order any of these parts from dry steam, they're all going to come with the proper plugs. So you just pull them out, plug them in, away you go. So basically we have a pot here that boils our water. Once it boils, it comes up. There's a dispersion tube up here. There's a tube up here with a T with little teeny orifices in it. Blows the humidity out underneath this pan. This fan then is going to blow air out underneath here so it absorbs that humidity immediately because it's steam. And then it comes back out and around the air, back out and shoots it above. So, you guys are a lot taller than me. You can probably see the dispersion tube. I'm not quite that tall. In here we're going to get in the controls in just a minute. This one's off in this room, so we're going to go to another room. We're going to get in the controls. I'm going to show you how to go into the diagnostics, how to tell you where everything is basically in them. We can go in, we can actually turn everything on and off one at a time to be able to see what's going on. We have, it's all low voltage on the controls, and then it goes to, of course, a contactor, which then enables our heaters. So all your controls and everything are in this side panel. So in order to get into this, it's the 2 screws, then this panel will slide, maybe. This panel will slide out of the way. So all your controls are there. We had a schematic inside every one. So when it's lost on the job, there's one here. So inside here we have all our controls. We have our contactor for the fan. We also have, well, we have a relay for the fan. We have a contactor for the heaters. Unfortunately on this one, on the heaters, it's all or nothing. There's not, because it's electric heaters, there's not a modulation or anything we can give it. You either produce some humidity or you're not. So in here, I don't know if we are controlling the humidity. I'd kind of guess we are not because I'm seeing a communications port here that they're probably giving us a signal. Here in a second we'll go over where I can show you where we can monitor their signal. We can actually trend it to see. A lot of times in these we have a lot of problems because humidity's moving like crazy. We can actually go in here and trend their signal coming in to see if they're giving us a wacky signal, and that's the reason why it's going up and down. In the drain valve here, there's a manual open. It's just like an Erie pop top type valve. Honeywell, they're all the same. Again, another valve, you need to get it. You can buy it over at RSD, Johnstone, wherever you guys want to get it from. So don't forget when you're popping this open, I recommend once a year we need to take these 4 bolts out of the box. There's 2 on this side, 2 on this side, the whole top lifts off. Every year we need to open this up, we need to clean it, but not only do we need to clean the bottom of this, you need to remember to clean your drain lines. Your drain lines are going to plug up, and when they do, just because you've got nothing in the pan, we're going to have problems, okay? There's the probes coming down inside. The probes, they're stainless steel. Sand them down once a year, just like a flame rod on a furnace. Sand them down, they're good to go. There's no reason why we need to buy new ones. So, can anybody tell me what this is? What its purpose would be?
Cool that drain water.
Okay. What's the rule on drain water?
That's a good question.
140 degrees. It's illegal to dump any water underneath 140 degrees down the sewer because when it gets that hot, you're getting it in a hot, musty place, it's going to grow a lot of algae and a lot of bacteria. So, purpose of drain cooler, fresh water line coming in. Sensor, if you need to adjust this, you do it through this little bolt right here. It's on a temperature. Hot water hits here, it mixes the cold hot water, fills up halfway before it allows it to run over and back down the drain. You want it to be 100-degree water? Adjust the thermometer for 100-degree water. Doesn't matter. You just got to remember, the lower you get that, it's eventually going to get almost room temperature where it's always going to be running so much cold water all the time. Okay? And that's done right here through this little Penn Johnson valve. So, any other questions on what you see here?
How many of these do we have?
I don't know. I'll tell you the truth. Do you guys know how many we have?
Are they on every floor? You probably know.
I was showed this Friday. So just because I had a problem, so.
So that does just this room.
Does this room only, yep. The air actually, if you reach up here, you can actually feel the dispersion tube and you can actually feel the orifices if you reach up there and feel on top. If you come back here and look in the stainless steel, you can actually see everything. If you look up in the stainless, you can see the reflection of the little orifices in that pipe. Can you see them? I mean, we're talking there's going to be 30 orifices. The purpose of the dry steam is it only takes 2 inches to absorb all the moisture. When it hits that airstream within 2 inches, it's absorbed every ounce of that moisture and it's done. So we will get no condensing or anything else up in here because of that. Now, if you notice on this fan, it's a Dayton fan, Granger. We try to get a lot of our stuff to where you can just get it off the shelf. About the only thing here you can't get off the shelf, of course, is the board, control board, and the display.
What about plug orifices? You ever get any ones up there?
I've never had one plugged. The purpose of the orifice too, might get in trouble if I draw on this piece of paper real quick. We'll draw on this one. Purpose of their orifices are, you have a round pipe that distributes the steam. That orifice comes in and it bends down and it comes right to the very center of that tube. Why would they do that?
Maximum steam.
Dry steam. You have wet steam, you have dry steam. Dry steam is always in the center of a tube. Wet steam, where it condenses and has a lot of moisture, is always on the outside of the tube. That's why your tubes always condense when you get cold or hot on the outside. So they're trying to pull that warmest steam, that driest steam, that's what makes it absorb so fast in the airstream. So if you notice in these tubes, they're all sloped back, so any steam that stops will actually flow and drop back down in the tank. Flash and come back out. Yep. No, it'll come back in this tank.
Into that tank.
And it'll flash right back and go back out. So, yep. We do have a little cooling fan in here in case this ever gets too warm in here. Turns on, pulls all the air out of here, try and keep it running right. Any other questions on these? Let's go play with a couple. Okay, so looking at the screen, it's going to tell us everything we need to know here. So he's going to tell you
190-degree water in the
190-degree water in the tank, and now it's also showing you the level in the tank.
halfway.
Okay? Yep, it's a little bit over halfway. So our output right now is 0% because
It's not calling.
we're over set point. So now in here, one of the things we can do in here, you got your main, your message, your alarms. You come in here to your alarms. It says it had an alarm clear back. I think our date's a little off.
Holy cow.
So yeah, it's a little. So it said that the signal was out of range that they was giving us. So that definitely tells us that somebody's doing it here. So we're gonna go back to our home screen, our main screen. So we've got our tank status. We hit enter. Our mode. This is one of the things that always come in. If you guys ever come into one of these and it's off, if somebody hits it to standby and goes back to home, this thing's just gonna sit here forever and never do a thing. Until somebody actually tells it needs to be running. We can come in here, we can manually, if you guys want to know if this thing's working, we can come back into tank status, we can go into drain. You'll notice here in just a second, it should start draining. This should start kicking some water in. So, and then it would sit here and run it down the sewer after this thing fills up. Remember, this has got to fill up about halfway full before it's doing anything. It's cold, not real cold, but it is cold. We can come in here, we can go back into the, well, let's get back out of here and go back into auto. And hear the fill valve kick on. So now it's filling back up because now we're a little bit low. I can come in here and I can go into diagnostics. And now we can go in here and we can go down to test outputs. So I can test my fill valve, I can test my contactor, So anything you guys want to know if this thing's working, we can test it all by just this thing, fan control. So our dry contact relay would be our alarm output to know if we got an alarm coming out of this thing or not. So see if I can get in here and change our So I just changed our set point up to 45 degrees. You can see our water level. I dropped it because of when I got in and opened the drain. So the mode is in what?
Standby mode.
Standby, is that good?
No.
Never run.
Auto.
So now our fan's gonna kick on. Even though it's not making humidity yet, they don't want that to start condensing in there, so they always turn the fan on right off the bat, even though it's gonna take it an extra minute. We can come in here and we can start seeing in the diagnostics again. We can come in here into I think it's in tank status. So we've got a 10 milliamp signal right now. The steam demand is 40. Well, there you go. That's what the demand is right now. What it's producing right now is 0 because we haven't started flashing. Our tank temperature. So our tank ohm signal, our high probe, we got no water on our high probe yet. Our mid probe, we got no water on it yet. Our low probe, we got water on it. Our airflow is good. Our interlock switch is closed. So, and then I actually allow these to run, I think it's 10,000 pounds of steam before we require service. It's going to come up and give you guys an alarm to tell you, look at it. And the only way you're going to know really how good your water is by getting in here and maybe in 3 months, open one of these up and look at it. If it looks good, don't worry about the rest of the rooms. Go another 3 months and pick another one. Open it up, it looks good, hey, we know we can go 6 months, you know what I mean? And after you guys finally, you're going to see them run for long enough, you're finally going to see a little bit of skill build up, and then you're going to know, okay, so 1 year we need to put all these on the maintenance for every year we need it, or every 9 months, or every 6 months, or depending on what they put in this room too, could depend on how often it's going to be. Do they put a lot of paper products in here that absorb a ton of moisture, or are they always bringing new stuff in and out? For us to say how often it really takes, it's kind of a loaded question because we don't know what they're doing in the room yet. So
your humidity level is going to be different depending on what they're putting.
oh yeah, you bring a pallet of paper in a room, it'll drop humidity like you've never seen. It'll absorb so much.
Standard set point, like 35%.
It was set for 35 when we got here. Yep. And so now we get in here, we can start seeing our tank temp still isn't quite hot enough yet. Why would our tank temperature drop from 184 to 179? We're adding water, so our water levels drop. Our water level's rising, so we're putting too much cold water in. So this thing will actually give you so much steam, you'll see smoke coming out the top when it finally turns on and starts to deliver. I have to look at the other one, model numbers inside, to tell you exactly how big these are. Any other questions on these? You want to play with them, go through them?
Lockout on that keypad.
No. No, but if you have a problem, pull the pads off. Put it inside.
Did you say there was a timed alarm?
There is a timer that says when it produces so much steam, it's going to go into alarm and tell you guys it needs service.
So it's going to go into alarm eventually, no matter what. Okay. After 10,000 pounds.
10,000 pounds of steam it's going to make. If this one sits here for, I believe it's 6 days idle and not being called for, it'll automatically drain the tank and sit here with no water in it. So if no demand happens, and it's either 6 or 7 days, it'll automatically drain itself and sit here to make sure it doesn't sit here and grow algae or anything else in the tank. There's one on each side of us, so if you guys want to jump in the room and start playing with them. The only thing in these you want to be really careful not to change is you're going to get into a screen where it's going to give you the serial number. The serial number is the configuration of what this was programmed to do. If you change the serial number, this thing will not work, I'll guarantee it. And it's a nightmare to get back to figure out what to put back in it sometimes. So, Or nothing like driving to Rollins, Wyoming to figure out somebody pushed the wrong button. So see, you can go in here and you can put in the water type you have, whether you have soft water, whether you're using deionized water, whether you use the softened water. Everything in these is programmed.
Hey, you better change the relative humidity.
Tank status. Go down. Go down another one. Right there. See, if you go back to the home, so escape, get out of here. You're going to see here in just a second. Yeah, you just need the home. You're going to see here now that it's finally full of water. Our temperature's climbing. So here in just a minute, it's going to start telling you the output is steam it's putting out. So they're noisy. Is the only problem with these because they do put so much. Have you guys ever seen the Nortec little bottle ones that hang on the walls? This is the equivalent of about 6 of them. So there you go. Do you hear your contactor pulling right there? So now you're going to start. See, now the output's going to be about 43%. So it's saying even though we changed our set point to 45%, we're only 38 in this room, 44% will still catch up. We still don't need even 100%. But remember, it's a contactor, so it's either all or nothing. We actually have these in natural gas, where I can give you an output from 10% to 100% output steam. So, and anything in between. So now if we was over there, the other one, you'd see, because we was blowing steam down and it's not hitting this cabinet, you'd actually see the steam and just blow right up the sides if we just take that top cabinet off. A little bit more dangerous. In here is what we're trying to do is get the steam to curl around, mix with that air real good. Before it finally comes up, it comes out the top.
You say Johnstone sells all the parts for this?
Not all of them, but they try to use more parts so you can buy off the shelf from anywhere you're at. So, of course, the circuit board you can't, and the VaporLogic 4 panel you can. I've never seen a circuit board go bad yet, except for I had a place that had a huge brownout and a big power that had a lightning strike. So that's the only place I've ever seen ruin a circuit board. So these guys are out of Eden Prairie, Minnesota. Anything can be here in the morning. We need it. We keep a lot of the parts on the shelf, but we can't keep all the parts.
There has been a fire alarm reported in the building. Please proceed to the nearest exit and evacuate the building.
Who wants to come up and change us? Who wants to come up and change it to get us back to 35% humidity in the room? Casey. You figure it out real quick.
May I have your attention, please? May I have your attention, please? There has been a fire alarm reported in the building. Please proceed to the nearest exit and evacuate the building.
So now we can go back in here. Remember, we get back in here to the diagnostics. Bank status. Input signal.
May I have your attention,
So we can still
please?
see the input signal actually hasn't changed yet.
There
The
has
steam
been a
demand is now down to 15% instead of 45%.
Proceed to the nearest exit and evacuate the building.
So if you want to get into here, you can actually get in here and watch this. And that's where I was saying, you can watch it where your signal's going up and down, up and down. A lot of times we get into these and they try and control your humidity to 1/10%. And so these things are on and off and on and off and on and off and on and off. It's kind of like, it'd be just like controlling your air temperature in a room to 10%. At 10. It's not going to happen. Give you 3 or 4 degrees. Same thing here. You're going to have a 3 or 4 degrees percent swing in a room, period. So up here at the top, it tells you you're on the 4th item of 18. So if you want to know how many you got, what all you can go through, it tells you what you've got. Right now, it would be producing 1.7 pounds per hour. So to give you an idea, I don't know if any of you guys have like the True Steam Honeywell in your house. Their big one can produce 12 gallons a day in a 24-hour period. 12 pounds in a 24-hour period. We're producing 2 pounds an hour. So, and this one will probably go up as high as 20 to 30 pounds per hour. So, any other questions here? Now the reason we're staying there, our set point's at 38%. We He was at 35.
Oh, 35.
Yeah. Trying to figure out why this will stay on. So now, if you come back to the main screen, now it'll actually tell you. You'll see your output change to 0.
How long did fan stay on after?
I think it's got about a 1 minute time delay. Yep. We'll know it here in just a minute.
What's your general time before it's coming on to steam? Does it have a time delay before?
Fan turns on as soon as it calls for steam. Fan turns on. So it doesn't wait and see, because this tank, you got to remember, if we just say your percentage. So say this door's closed. If somebody opens that door, your humidity could drop by 5 or 6% in this room. I mean, just like that. So this tank can be hot, so it can produce steam almost instantly the second that turned on. It doesn't follow whether the tank's halfway out of water, whether we just went through a drain cycle, whether we just went through. It doesn't follow that type of stuff. It just
May I have
knows
your attention,
we
please?
just called for
May
steam.
I have your attention, please?